Hey everyone, how are you doing today? I hope you're doing well. I hope that you're staying safe and doing what you need to do to keep you and your family safe. I miss you guys, and I hope you're doing very well. So what we're going to do today is we're going to carry on with what we were learning in the last couple lessons. And you can see here I picked a function that has as much as you possibly could add into a trig function. It's got the A, the B, the C, and the D term in there. Now, I'm not going to be asking you just to identify what is A, B, C, and D. What I'm going to ask you to identify is I'm going to want you to be able to tell me what the amplitude, the new period, or just the period, the horizontal shift, and what the vertical shift are. Now, conveniently, what's happening with your vertical items, in other words, the amplitude and the vertical shift, those are very easy to spot right from your function. Your amplitude, remember, is the vertical stretch. It's the distance from the middle of the graph to the top of the graph. And that number is just the number that's out in front of the graph. And just as conveniently, your vertical shift is going to be the number that's at the back of the graph, the number that's getting added into the graph or subtracted. Now, it would be really convenient if the new period was just that 2 and your horizontal shift was pi, to the right pi, because that would agree with what your rules used to be and with what we see here. But it's just, sadly, it's just not the case. That's not what our period and our shift will equal. So I'm going to show you again the tricks for the period, and then I'm going to teach you the trick to find the horizontal shift. So for the new period, remember the trick was you take your bx and you set it equal to the normal period. So when I say that, remember for both sine and cosine, if you didn't have any shifts and you didn't have any stretches, your period was equal to 2 pi when you graph just y equals sine of x or y equals cosine of x. I make a big deal over it's the normal period because with your tangent function, remember your period of the normal tangent function was equal to pi, not 2 pi. So we're going to set this bx equal to the normal period, and we're going to do what comes naturally next. We're going to solve for x. So we get here x equals pi. So your new period will be pi long. In other words, this will be a graph that was smushed. So it's only half as wide as a normal sine graph. All right, now the new thing to us is this idea of horizontal shift. Normally, you would be able to just look at the graph and say, oh, I've got minus pi, that means I'm moving to the right pi. But normally we didn't put a number in front of our x term. If we had, you actually would have had to switch to this trick that I'm teaching you here. What you're going to do is you're going to write everything that's inside the parentheses, but only the parts that are inside the parentheses. And you're going to set them equal to 0. Once you do that, again, you're going to then do what comes naturally. You're going to solve for x. And we get x equals pi over 2, not just pi. So this tells me, just like the plus on the vertical shift told me I was going up 2, my horizontal shift tells me, because it's a positive number, that I'm going to go to the right by pi over 2. Okay, so we have all that established. What does that now mean for our graph? Now, I am going to have you graph again a couple of these by hand because I want you to play with how they work. But then by the time we take the midterm, I am going to be shifting to having you use the graph and making the equation itself out of that, or having you just identify the horizontal shift, the vertical shift, the amplitude change, and the new period. Okay, so as I was making my videos, I kept having an issue with erasing my amplitude, new period, etc. All my data that I need for my sine function. So I'm going to redo it this way so I won't end up erasing it. So when you are graphing these functions, I recommend that you do go in a specific order. I recommend that you handle the amplitude and period together, and then the horizontal and the vertical shift together. Break those up into two groups. So what I'm going to do here is I'm going to start by graphing the equation y equals 5 sine of 2x. So I know that because of that 2x, my new period is going to be pi. So remember, your sine functions always start in the center, and then they end at the end of the period. And if you divide it up into these 4 equal sections, then you're going to always alternate between the maximum 0, minimum 0. Normally, if it was a normal sine function, my maximum would only be 1, because sine only goes up to 1 and then comes back down again. But because I have an amplitude of 5, this is going to have a maximum of 5. And then you'll go to your 0, and then on your next quarter, you're going to go to -5, and then to your 0. And once you see that one complete period, then repeat that motion on the other side, where you're going to have your minimum, 0, maximum, 0. And just to show you that I am not lying to you, over here, if I graph those two things together, you can see I did a pretty good job. Honestly, more on than I sometimes end with my sketching, but the most important parts, the minimums, maximums, and zeros, those are all right where they need to be. So once you have that together, then you want to do your shifting. So for your shift, let's pick a new color. Let's do that one, looks good. I know that every point I'm going to move over by pi over 2 and up by 2. So this point right here, my center point, now is going to be here at pi over 2. And then when I travel by pi over 4, this point right here is going to travel over pi over 2. And then it's going to travel up from a y value of 5 to a y value of 7. This point right here is going to travel over pi over 2 up 2. It had a y value of 5, now it's or -5, and now it's going to have a y value of -3. This point right here, let's see. Okay, let's do this one. This point is going to go over pi over 2 up 2. Over pi over 2 up 2. And you start to see what your new graph is going to look like. Right there. Now, this right here has taken into account all our amplitude changes, our vertical shifts, our horizontal shifts, everything we can throw at it. Our new function now has. So if I come turn this one on, voila, that red function right there, you can see it goes right through where I labeled. Now again, I'm going to have you practice drawing out a couple of these on your own, just because it helps you to understand just a little bit better what each piece means, what amplitude means, what new period means, especially new period, because that one is just so different from what we've done before. Once again, if you do have questions, please do join my Canvas conference call. And in this next week or so, I would like to have a conference call with all of my math classes together, just so we can touch base, since we haven't all been on at the same time necessarily yet. Now, one of the reasons that I do think that this is easier to handle your amplitude and new period changes first, and then your shifts, is when you start adding them all together, it just gets so complicated with this many pieces that you're dealing with. Now, you could, of course, absolutely make a table and just say, okay, I'm going to try x equals 0, pi over 4, pi over 2, etc., and make a table and plug them into your original equation and graph your points that way. No doubt, absolutely. If you feel more comfortable doing that, please go ahead and do that. But I'm going to keep showing you these ways with graphing more than one thing at a time. So, for example, graphing the orange graph and then using it to move to make the purple graph. We'll do a couple more examples, and then I'm going to turn you loose on the problems. So let's do something like, let's do something where I flip it upside down. Let's use the cosine function. I'll get to the tangent in a little while. I just want to play with sine and cosine for now because they're so similar. Let's give it a period of, let me think. I'm going to say pi over 4. Let's move it to the left by, I'm going to move it to the left by pi over 4. And let's move it down 3. Alright, so you can kind of see where this graph is already. I'm okay with that. I'm going to come and I'm going to change my window again. That I want to have something that is going to show me roughly 2 periods. Right now I can see that this is not even quite one full period. Let's change it to something like negative 10 to 10. That'll be pretty reasonable. Okay, so you can see where it's at. Looks like I don't need a lot of these y values. So let's go ahead and change that as well. Okay, now I'm going to take this away from you. We're going to go back and we're going to find the amplitude, the new period, and all of that other stuff. So, amplitude and vertical shift. Those are the easy ones to find. How is it that you find them? You look just right at the equation. This is where size. There's the one I want. Well, that barely did anything, didn't it? I miss you guys, and I miss the smartboard. I am set up a little better than a lot of the other math teachers at home, I do think, for this, but I do miss the smartboard. Okay, so on our function, we can see that the amplitude and the vertical shift just come right from what we see on the equation. My amplitude's the number out in front, and I have -3. Let's make that a little bit bigger. -3. And my new period, my vertical shift is also going to be -3. So in other words, I'm going to go down 3. But that horizontal shift and the new period do take a little bit of extra work. So for the new period, and you can go in either order for these, it really doesn't matter. I'm going to set my bx over 4, or bx, equal to the normal period for my cosine function. And then piece by piece, I'm going to use this to solve for x. So I get that my new period is equal to 8. I'm going to take for my horizontal shift, I'm going to take everything that's inside those parentheses and set them equal to 0, and then use that to solve for x. Just move one piece at a time. I personally like to multiply by reciprocals. There's a couple ways to get rid of this, but if I multiply by reciprocal, there's one on top, one on bottom, one on top, one on bottom. And whatever I do on one side, I do to the other. All right, so conveniently here, we see all we're left with is that negative. Remember, when everything cancels, there are still ones left over. So what I get here is x is equal to -1. Or in other words, I'm going to shift to the left by 1 unit. Just notice how much my word down looked like clown. Okay, so notice here, let me go ahead and clear all this. Notice that with this new period and horizontal shift, with what is happening on the x-axis, I'm going by ones, not some division of pi. So this actually means that it's going to be more helpful to change this so that I'm not stepping in something related to pi. Here, if I go by ones, I think that would be wonderful right here. So start again by graphing just the amplitude and new period change. So in other words, I'm going to graph just y equals -3 cosine pi x over 4. Now with your cosine graph, let's go ahead and shift this a little bit, because normally your cosine would go all the way up to 3 and -3. Let's see. I'm trying to make sure I have something that will show for both. That'll be perfect. Okay. So normally your cosine function, remember, normally it would start at your maximum value and then go down to your minimum value. Let's see, your period would end by 8. We're going to divide it up into 4 sections, so that means 1, 2, 3, 4. So normally you would start at the top, then have a 0, and then have a minimum, and then have a 0, then have a maximum. But in this case, I do have that negative in front of the 3. So what it's going to do is it's going to flip all of my points upside down. So my zeros will not be affected by this, but my minimums and maximums will switch places. So now this is going to start at the minimum and then have a 0, and then go up to a maximum of 3, and then a 0, and then have a minimum again of -3. And I can see there 1 complete period. And then I can repeat it. 0, maximum, 0, minimum. And just to verify that with you, I am going to show you over here when I graph this function, y equals -3 cosine of pi x divided by 4. That goes right over the points that I had predicted with my line. Now, once you have those points in place, then let's talk about shifting our graph wherever we need it. In this case, I'm going to take every point to the left 1 and down 3. So this 0 here is now here. Take this point to the left 1, down 3. It's now going to be here. This point to the left 1, down 3. This point to the left 1, down 3. And you're going to keep doing this to every point. Now, you might choose to go faster than I'm going right now. That is fine. Right now, I'm trying to do the lesson for you, and I do encourage, if I am going too fast for you, feel free to stop the video, rewind it, watch it again, play it at half speed, go through these things a couple times. That is going to be the advantage that we do have here with our distance learning, is normally in class you'd hear me go through it once, and then that's really kind of the only time you get the full lesson. But here, as we're doing our distance learning, you can go through this as many times as you need to. And I am trying to go through this in a little bit more detail and a little bit slower and more carefully than you would maybe see in your university physics class. Let's change that color just so it stands out a little more. Let's go back to that. Well, let's go to black. Let's make that a little bit bigger too. So there's our cosine function, and if I want to turn this back on, you can kind of see it underneath my graph. Let's go ahead and clear that all off. You can see that it is down where we predicted. The act of practicing with the graphing, again, I know that you guys in your life, you're going to have access to graphing calculators, a lot more than many generations have had. But again, I want you to practice graphing it by hand just to get used to how these pieces work. Okay, let's do one more. Let's say I'm going to go 7. Let's do another cosine. Let's go back and make it a larger number. Let's say that I'm going to use 3x. I'm going to use 16x. All right, now let me think through for a second. I'm going to shift it. Let's shift it by 3 pi divided by 4. And let's move it up 2. All right, so I have something super, super crazy here. That's okay. You know what? I'm not going to pick my window until after I go through and identify all of my important pieces. So here, let's get rid of these. Get ready for our new problem. Should have done it this way last time. Okay, so from our problem, we can see just straight up that our amplitude is the number that's out in front of the function. Our amplitude is going to be 7. Our vertical shift I didn't erase the whole thing. Our vertical shift is going to be equal to the number on the outside that we're adding or subtracting. We're going to go up 2 units. For your new period and your horizontal shift, it will take a little bit more work. So for your new period, we're going to set your bx equal to the normal period. We're going to then solve it for x. And I see that I'm going to get x equals pi over 8 when this simplifies out as my new period. My horizontal shift, I'm going to set everything in parentheses equal to 0. I'm going to move things one at a time over. And dividing by 16 is the same thing as multiplying by 1/16. I prefer multiplying by 1/16 here because I already have a fraction. I don't like to show that I'm going to divide by a fraction because I don't like dividing a fraction by another fraction. All right, and I end up getting here x is equal to, there's no cross canceling that can take place. All I can see is I'm going to get 3 pi, and 4 times 16 is 64. Okay, so my horizontal shift will be negative 3 pi over 64. Kind of a crazy small problem compared to what I've had before. So I know that my amplitude is 7, plus I'm going to move up 2. So that means on the y-axis, it's going to be a good idea to go up at least to 9. I'm going to go ahead and take it a little bit past 9. And then because it does go down to 7 before I shift it, I am going to also take this down to negative 7.5, just to begin with. Actually, I'm just going to go ahead and call that negative 8, and call this one negative, or call this one positive 10, just so I can see them on my graph. I like that a little bit better. Okay, so my period, once again, has to do with pi's, and so does my horizontal shift. So what I'm going to do here is I do want to bring back this idea of stepping by pi. Let's have it step by pi divided by 64, which it's not really going to do right now because that is going to be pretty tight on my x-axis. But on my x-axis, let's have it show a negative period, so in other words, negative pi over 8. And then have it go to a positive pi over 8. I still don't love that it's using decimals here, but I'll accept it. Okay, so I like how this all looks. We're going to start by graphing. Let's pick a new color. We're going to start by graphing just your new amplitude with your bx, or in other words, to show what's happening with your new period. Cosine normally starts at the top. In this case, the top is at 7, not negative 7 because I don't have it flipped upside down this time. And you're going to end here at pi over 8. And then let's see, if I divide this up into 4 pieces, looks to me like I'm going to have here down to 7, and then a 0, and then up. There's some wonderful symmetries here that you can use to your advantage. So I know that my complete period happened at pi over 8. I divide it up into 4 sections, and it always alternates maximum, 0, minimum, 0, maximum. Or maybe it starts at the minimum, 0, maximum, 0, minimum. Or if it's a sine function, 0, maximum, 0, minimum, 0. But that pattern just is always consistent. So if you get used to the starting values, you can find the rest of them. Once you have the period on the positive end, repeat what you've got over here on the negative. And go ahead and show me those 2 periods of my function. Again, I can see a period because it's how far you travel before you start to repeat the motion. All right, so once you've got that, and again, let's prove to you that I know what I'm talking about, and even though I know this is going to go away as soon as I start working, we have here y equals 7 cosine of 16x. Okay, don't know why that makes it go away, but there we go. See it in the same place. And then now we're going to go ahead and we're going to incorporate our shifts. Getting ahead of myself with my colors here. Okay, so my horizontal shift tells me that I'm going to move 3 pi over 6s. And if you remember, here I set it so that each of my grid lines was going to be at a pi over 64. So that means that any given point that I'm going to use it's going to move 1, 2, 3 of those to the left, and then move up 2. See, I don't quite like using, let's go ahead and change this one so that they contrast each other a little bit better. All right, so I'm going to keep taking my points, move them over 3 pi over 64, and up 2. I'm going to move it over 3 pi over 64, and up 2. I'm going to move it over 3 pi over 64. I'm going to move it up 2. And you see our pattern emerge here. Let's see, let's do this one. Over 3 pi over 64, up 2. Now I do promise I'm not going to give you any that have as complicated numbers as I have right now. So don't worry about that. But this whole process, that's what I really want you to get used to, is graphing this piece by piece. Let's see. 1, 2, let's see, 2, 3 to here, and then up 2. There we go. And if I turn on my graph, there we go. So I am going to be asking you some quizzes. Like I said, in the end, what I'm really going to look for is, are you going to be able to identify the amplitude, new period, horizontal shift, and vertical shift from your own graph, from your equation that you're given. And then we are going to work our way towards, what if I give you the graph? Could you find the equation out of it? And we're going to play with that. So please, 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 I know that this is something that's going to take a little bit to wrap your head around, so please do contact me if you have any questions, and I will be here for you as we work our way. I am trying to go through this a little more carefully and a little more slowly than I would if we were all together. So yeah, just let me know. Hope you're doing well. Continue to stay safe. Wash your hands a lot, and I'll talk to you next time.